magnetic field of a supermassive black hole has been revealed by the Event Horizon Telescope. I'm going to explain to you in a real easy way. Let's get started. So first, what is the Event Horizon Telescope? In astronomy, if the diameter of the telescope is bigger, your spatial resolution is better. So if you want to see tiny things like a black hole shadow, then you need a very big telescope. But even the biggest telescope, such as a 30-meter telescope here in France, the black hole shadows are too tiny. The size of the black hole shadow is something like 20 micro-arc seconds. The circle is 360 degrees, right? So 1 degree is something like this. And then 1 degree, 1/60th of 1 degree is 1 arc minute. And 1/60th of 1 arc minute is 1 arc second. And then 1 micro is 1 millionth of 1 arc second, is 1 micro arc second. And a black hole is something like 20 micro arc second. This is like the size of an orange if you put it on the moon. So astronomy telescope need to take a picture of an orange on the moon, that if the telescope wants to take a picture of a black hole shadow. This is how challenging this project is. So if you want to see that tiny thing, you need a bigger telescope. Then how do we do that? What Event Horizon Telescope did is like this. They connected many radio telescopes around the world and they combined it as one telescope to make a giant telescope with the size of the Earth. So see, here are telescopes that's joining into the Event Horizon Telescope observation. Event Horizon Telescope is the combination of those telescopes. And some are in Antarctica, Hawaii, America, Chile, and by combining all these, they made a telescope that is the size of the Earth. So here's a movie of the Event Horizon Telescope. By connecting telescopes around the world, so they make one gigantic telescope the size of the Earth. So one in Chile, North America, Mexico, Hawaii. And then 2 years ago, they successfully took a picture of a black hole, a supermassive black hole M87. So this is a galaxy, giant elliptical galaxy M87. A jet is coming out from there. This is 5,000 light year scale. If you magnify the center, this is 0.5 light year scale. And then now they go to this 0.01 light year scale, successfully took a picture of a shadow of a black hole. It's a black part of the black hole at the center of the black hole. This is the first time humankind has seen the black part of the black hole. Usually when the telescope resolution is not good, you see black hole as a bright point like this. You cannot resolve, you need a super high angle resolution to resolve out the black part at the center, because this is, say, diameter is only 42 micro arc second, or this is 0.0000001 degree, or as I said, this is like picturing an orange on the moon. This is how tiny it is. But this was 2 years ago. This time they pictured magnetic field. How they did that? Magnetic field, if they exist, then there's a hot plasma around the black hole, and there are some charged particle in this hot plasma, and a magnetic field is gonna bend this motion of the charged particle like this. If charged particle, it's electronic current, right? So it's bent by magnetic field, and when energetic particle is bent by magnetic field, this radiation called synchrotron radiation is going to come out here. And one particular feature of this synchrotron radiation is this synchrotron radiation is polarized. When the charged particle is bent by the magnetic field, the light coming on is polarized in perpendicular to the magnetic field. This is one particular feature. So that means magnetic field is invisible, so it's very difficult to observe. We cannot see it with telescope. But by observing this polarized light with telescope, then we can investigate the magnetic field around the black hole. That's what they did with the Event Horizon Telescope. And this is magnetic field pictured by the Event Horizon Telescope. Again, this is tiny 40 microarc second, and this thing is magnetic field they have. And first of all, it's very interesting that magnetic field is stronger on this side than this side, and it's almost the direction is azimuthal direction. This is a new discovery. So from that picture, what did we learn? Well, this is the first time we saw magnetic field around the black hole, so close to the black hole, so that's amazing achievement. But we can also do science with this picture. So one thing is only part of the ring is significantly polarized, so that means only part of the ring is magnetized and a nearly azimuthal pattern. And then by comparing this picture of the polarization pattern with computer simulation models, we can estimate the density of the plasma gas, and that's 10 to the 47 per cubic centimeter. And also we can estimate magnetic field strength, which is about 1 to 30 Gauss. And the electron temperature of this hot plasma gas is about 10 to the 10 Kelvin. It's very high temperature because it's around the black hole. And also we can also estimate how much mass is accreting to the black hole, how much mass is going into the black hole. It's about 10 to the minus 4 solar mass, the mass of the sun, in every year. This is the amount of mass going in there. And we can learn all these from that magnetic field picture. Moreover, it looks like this magnetic field is changing. This is surprising discovery. So the observation was over a week, April 5th to the April 11th. By the way, this observation was done in 2017 and now it's 2021. It took the team for 4 years to analyze data, and they use 5 different methods to analyze data to make sure the result is correct. And these 5 different methods reach the same conclusion, so that's why they published the paper now. Anyway, let's look at the data day by day, April 5th, 6th, 10th, 11th, and it seems here magnetic field is changing. It's more here, weaker here, stronger here, but April 10th it's around here, so possibly magnetic field is changing as a function of time. This is also very interesting discovery. We didn't expect this because this black hole is supermassive, and a supermassive, supergigantic black hole needs a long time to change its morphology or brightness. So we didn't expect it to change in 1 week, but it seems like it's changing. Well, researchers are careful, so they haven't concluded in this part yet. They need further observation, but if confirmed with further observation, this is very interesting discovery. This is a little bit technical, but this polarization, average polarization angle, on April 5th, 6th, 10th, 11th, it seems angle is maybe changing a little bit. That's very interesting. Okay, so that's all. Again, this is a beautiful picture of the magnetic field around supermassive black hole. If you have questions, please ask me below. If you like the video, please like it and then subscribe to my channel. Okay, see you next time.